So welcome to 4K's Private Tuition. I'm your host, Seshung. In this particular video, we'll talk about aldehydes and ketones, which are carbonyl compounds. They contain that carbon to oxygen double bond that I'm showing on the screen. So to my left, there is propanol, which is an aldehyde, and to my right is propanone, which is a ketone. Okay, so you should know that this carbonyl group is polar. It is a slight negative charge. This is because oxygen here is a higher electronegativity compared to carbon. Therefore, the electron cloud is going to be shifted towards your oxygen, giving it a slight negative charge, leaving our carbon electron deficient and hence with slight positive charge. So this makes this bond vulnerable to attack by nucleophiles, which are electron pair donors. So it's going to undergo nucleophilic addition reactions. This bond, for example, here we can look at the reduction of aldehydes by the reducing agent sodium tetrahydroborate, aqueous sodium tetrahydroborate. So we are going to reduce here our aldehydes to primary alcohols. So this is done, of course, under room conditions where you simply have to gently warm the reagents for this reaction to take place. So you're supposed to write the reducing agent using capital letter H in the equation as shown there. Okay, you can also reduce ketones, but this time to secondary alcohols using the same reagents. So the mechanism is going to look like this. Your reducing agent is going to produce the hydride ion, which acts as a nucleophile. So you can see that it has a lone pair of electrons there. So it's going to donate that lone pair of electrons to the positively charged carbon. And in doing so, the carbon to oxygen double bond, one of those bonds is going to break such that all the electrons are going to go towards the oxygen. So it's going to be, if you still remember, this is going to be heterolytic fission. So one of the pi bonds there is going to break by heterolytic fission, and all the electrons are going to move towards the oxygen. Now, the oxygen is going to attain a negative charge, and you can see that it also has a lone pair of electrons there with a negative charge. So remember, this reaction occurs in an aqueous solution, so we have water molecules, and water molecules are also polar. So we see that the hydrogen in the water molecule is slightly electron deficient, and therefore the negatively charged oxygen with a lone pair there is going to donate the lone pair towards the hydrogen. And again, that bond in water, the covalent bond between oxygen and hydrogen in water, is going to break. Of course, this is also a heterolytic fission, and we are going to have now hydrogen attached to this molecule, forming our alcohol, and we're going to produce OH minus ions from the water. So this is an example of nucleophilic addition reaction. You can test for aldehydes or ketones using 2.4 dinitrofenyl hydrazine, which will give you a yellow or orange precipitate with either ketones or aldehydes. So the problem is that with this reagent, you can't distinguish between aldehydes and ketones. It will give a positive test with both these compounds. So you need other tests that can distinguish for you between aldehydes and ketones. So we're going to look into these. So what you need to remember before we look into this test is that aldehydes are easily oxidized by weak oxidizing agents, whilst ketones cannot be easily oxidized. So this is the basis for all the tests that are going to distinguish these two. It's due to the fact that you can easily oxidize alcohols, whilst you cannot easily oxidize ketones. Okay, so the first reagent that you can use to distinguish between these two is Tollin's reagent, which is also commonly called the silver meter test. So toluene is made by mixing 4 cubic centimeters of silver nitrate and sodium hydroxide, which will give you a brown precipitate of silver oxide. And then after that, you add several drops of ammonia, which is going to give you a soluble precipitate, producing a clear solution with no color. So you're going to get a colorless solution. So your Tollin's reagent can be mixed with an aldehyde, and you need to remember that it contains silver ions. And so when the oxidation takes place here, the silver ions are going to be reduced to silver, which will give you the mirror that forms around the walls of the test tube. So this is why it's called the silver mirror test, because of the silver that would form around the walls of your test tube. So we are going to have our aldehyde here being oxidized to a carboxylic acid by this Tollin's reagent. So when you see that silver mirror, this shows that the compound was an aldehyde. So this is done when you mix the reagents. You have to warm gently in a water bath at 50 degrees Celsius. Okay. Okay, so let's move on. We also have what's called Fehling's reagent, which is an aqueous solution of copper 2 sulfate that has been mixed with an aqueous solution containing a strong alkali plus a compound called tartrate. So this Fehling's reagent will also give you, it contains copper 2 sulfate, as I have just said there. So this Fehling's reagent will react with aldehydes if you warm gently. What's going to happen is that your aldehyde is going to be reduced, it's going to be oxidized to a carboxylic acid. However, here it's the carboxylate ion which is formed but the oxidation takes place in that manner. So your copper 2 ions are going to be reduced in the process to copper 1 ions, and they are going to form copper 1 oxide. And this will give you a colored precipitate. It will give you a brick red or orange brown precipitate. So when you see a brick red or orange brown precipitate with Fehling's reagent, you know that the compound was an aldehyde. Okay, so the last test that you can also carry out is the Benedict's test. So Benedict's it contains some copper 2 ions as well. So it's going to give you the same color changes. So you can use Benedict's test to test for aldehydes. You have to warm the aldehyde with an equal amount of Benedict's solution, and you're going to form your brick red precipitate as before. So you need to know that all these tests, your ketones are going to give a negative test with all the 3 reagents that we talked about so far. So in that manner, you can distinguish between your aldehydes and ketones. So hopefully this will help you to understand aldehydes and ketones. See you in another video.